we have discussed so far the motion of a particle, and we have discussed the concept called pure translation of a particle.
Yes.
Okay? So that's the word. It is moving. The particle is moving in or in simple words, if you say a particle is moving in a straight line, then you are going to choose some reference point, and then you are going to use that reference point and create the mathematical conditions and say that it is moving in a straight line. Fine?
Yes.
Clear, students?
Yes.
Right. Now, so now here I think till this point you have got a clear picture, like translatory motion of a particle or pure translation, or if it is moving the straight line. So now you see the next aspect is introduction to rigid body dynamics. That means now what rigid body dynamics now means what? You are going to consider all the particles simultaneously that is making up the rigid body. Okay, now you see this is a rigid body. Okay, now this body if I throw, so it is going to make some motion, right? Now you have to define that motion. So this can move like this, okay, or this can move like this, right? So now you see if it moves like this, what do you call this type of motion, and why do you call that type? That is so and so motion. Okay, or if it is going to move like this, then what type of motion is this? Or it is going to do like this and keep moving, what type of motion is this? Or it is moving like this, what type of motion? No, we know. So we are going to give names to these types of motion. But what is important is just not the names. You have to give the math model for those types of motions, not only giving names to that. Okay, so that is what we are going to learn here. Okay, so we will keep learning. There is still time. Okay, so I already explained the concept of rigid body to all of you. So just for the sake of brevity, you can see here that a rigid body is an assemblage of large number of particles, material particles to be very specific, which do not change their mutual distances under any circumstance, or in other words, they are not deformed under any circumstance.
Yes.
Actual material bodies are never perfectly rigid and are deformed under action of external forces. When these deformations are small enough to be considered during their course of motion, the body is assumed to be rigid. Hence, all solid bodies such as stone, ball, vehicles, etc. When they say ball here, it is rigid ball, okay, not rubber ball. Vehicles, etc. are considered as rigid bodies while analyzing the translation as well as rotation motion. To analyze the rotation of a body, relative motion between the particles cannot be neglected, and the size of the body becomes considerable factor. So that is why we study rotation motion and also known as mechanics of rigid bodies.
Yes, sir. Yes.
Fine. Now you can read this for 1 more minute, and if you want to take down the key points here, you can please note one, if you want to.
What is the difference between particle and material particles?
What is the difference between this one? Okay. See, material particles will have inertial mass.
Yes, sir.
That's it. Okay.
Sure.
Just read it once and just write it. Aram se. Don't go on seeing that and copying it down. That's not the way to learn. You have to understand it. See, I am giving you time so that you read, concentrate, understand, and in your own words you write, and then compare. So what you have to do here is, what are the key words here? I told you here, write down the key words. Assemblage of large number of material particles. Okay, they do not change their mutual distances. Okay, okay, they are not deformed. So under the action of external forces, their relative positions will not change. Okay, so these are the keywords. That's all. You write down those. Don't write everything there. That's all given in your textbooks. Right. That's great. See, now don't ask me, what is there in the black line under, and I'm sure nobody will ask except that boy. Okay, when I tell you to concentrate on something, you are concentrating on something else. See, those definitions, I have taken it from different sources. Okay, I don't want to simply go on repeating those. Okay, so I said fine, it's enough. Now, translatory motion of rigid bodies. Okay, now general motion of rigid body in a plane. So I think now you can see here that we have started using a rod, a thin rod. Now we have started using. That is the first rigid body that we have considered.
Yes.
The first rigid body we have considered. Now we will now consider the motion of a rod. What is a rod? Collection of points which are, if you arrange it, it's going to become a straight line. It's going to be a straight line. And now the motion of a rod will first understand and give a math model for that. Okay, as you can see here, we can use the above ideas to study the motion of a rigid system of particles in a plane. The simplest system of particles you can think of is collection of particles arranged in a straight line. We call this as a thin rod or simply rod. What are the various ways in which the rod can move? Okay, a rod can move, it can move. But now we have to create a math model for the motion. If I say the rod is moving like this, I give the math model, then you should be able to visualize how it is moving. Okay, so what are the various ways in which the rod can move in the plane? Let us place it in a plane in which we have drawn reference line OX. O is the reference point on it. Okay, now C is the center of the rod. Write the position vector of C with respect to OBR and let ACB make an angle theta. Okay, that's what obvious. Okay? So now if I say the rod is translating, translating. Can you see? The rod is translating. The rod is translating. The rod is rotating.
Yes, sir.
Correct? So now you have to give a math model for these two concepts.
Yes.
A rod is moving and the rod is translating, the rod is rotating.
Yes.
Okay. So for that, what we have done is we have chosen, in this case we have chosen C as a point, and then we have taken a reference point and we have drawn a line to that. And then we have also formed another angle theta. See, we are creating some things like this.
Yes, sir.
Okay.
Yes, sir.
Now, if I want to say the rod is translating,
Yes.
then how will you give the math model for this? So,
Delta R bar by modulus delta R bar constant.
pardon? What did you say?
Delta R bar by modulus of delta R bar.
Okay. Delta R bar by, what did you say?
Modulus of delta R bar.
No, gentlemen, you are wrong. I said pure translatory motion.
And if that is theta, then
Yes, it is. Yes, and also theta is I said theta is.
Theta is constant. See, now the position of the rod is here, right? Now it will move to a new position, which is B dash, C dash, A dash. Hello? Hello? It will move to a new position, B dash, C dash, A dash. Now if you draw a line through ABC or ACB, it should make the same angle with respect to the reference axis X.
Yes, sir.
Okay? Then we say it is doing what? It is translating.
pure translation.
Wait.
Yes.
Wait, it is translating. I didn't say pure translation.
Yes.
I didn't say pure translation. It is translating. Come on, think. Your friend said pure translation. Should it be only be pure translation?
So we cannot apply that concept because we need to define for extended bodies.
This is an extended body, man.
Yes, sir, but we did for only particle body.
Now we are taking a rod, I told.
So we said angle with the reference axis is constant. So
see. Right. See here. See. Now I wanted somebody to point out like this. So now this is point C, A, B. So if you extend it, it is making an angle theta. Okay. Now, well, the rod has moved here, from here to here.
Yes, sir.
Okay, A dash, B dash, and this becomes C dash. Now again, with respect to the reference line, it is still making angle theta. Okay, this is one condition. Okay, now, so the other condition. What is the other condition?
Yes,
It can be like this. It can be like this.
Yes.
Correct? Till this angle is theta.
Yes.
Yes.
So you should make the difference here. So now, from here to here, it is one type of motion. From here to here, it is another type of motion.
Yes.
There is one common qualifier for both. That is, both are performing translated motion.
Translated.
Because the thetas are same.
Yes.
However, now if you see the if you trace the path of A, if you trace the path of A, so what is this? This is the path moved by particle B. This is the path moved by particle C. This is the path moved by particle A.
Yes, sir.
Okay, they are parallel to each other, and they are straight lines.
Yes, sir.
They are straight lines, correct? So therefore, for this you will attach the word pure translated motion.
Yes, sir.
Pure translated motion. Whereas here you see it is moved. It has moved like this.
Yes, sir. Curvilinear.
Yes. So this qualifies for curvilinear translation.
Yes.
Now what is common in both? This angle theta is same, and the path traced by each of the particles are parallel, no doubt. Okay, but only thing is here they are straight lines, here they are curved lines,
Yes.
and therefore
Yes.
this qualifies for curvilinear translation.
Yes, sir. Yes, sir.
So,
Yes.
if it moves like this only, like straight lines, not curved lines, then also it's pure translation.
Okay, fine. Now your friend is asking a question here, so somebody should answer it. Somebody should. Yes, you repeat the question.
Yes.
From that position, center position, it is moving in curvilinear path to that coordinate, new coordinate. If it follows a straight path, like
So he is telling now this point, this point, this point. That is, this is A dash, this is C dash, and this is B dash. It has moved like this. It has moved like this. Then what set of motion is this?
like this.
Like this.
No, like this with parameter
See, you are telling like this,
and upwards, both like this and like this.
like this,
Yes.
like this.
Repeat
He is telling it moves like this.
Yes.
And then data with respect to
Curvilinear. Yes, sir. Curvilinear.
No. He is brilliant boy, yeah. Okay. So what?
See, this something said where
Forward and upward
curved
in
path
the
is
same
straight
time.
path.
Like XI.
XI.
So in curved path village, straight path.
There
Not
will be
the
a
constant.
straight line. There will still be straight line.
There will still be straight lines. Hello, Arun. There will still be straight lines.
But pure translator.
It is straight line. Straight line means pure translator.
Yes, sir.
Pure. See, if these lines are parallel. First of all, these displacement lines are parallel. Here, see, the displacement lines are parallel. The displacement lines are parallel, no? See, this point and this point. Okay, so these displacement lines are parallel.
Yes.
And they are straight
Yes.
lines.
Yes.
They are parallel and they are straight lines. No, this part.
Yes, sir. Then need a pattern.
See, it is not curved.
Yes, sir.
Okay. So pure translator means that will be straight line. Any straight line.
So this is not straight forward. So, like if you take the concept of center of
Center of mass alla beda. Center of mass alla beda. Don't bring anything like that.
Like that particles are not this thing along with straight line. Like daughter
Arey yaar,
particle of
see that is what that is why I am drawing all this. Come on, use your common sense. Use your common sense. Who told you that the straight line should be drawn like this only? Can I not draw the straight line like this?
Sir, but that is not.
Hey, listen. Now you see, you are telling me that it is not. These straight lines are not in this direction. I am telling you, no. You draw the straight line. See now what is happening to this point. This point keeps moving like this. Is it not a straight line? Good. You should get these doubts. You should think. No doubt about it. So the basic thing is that these path traced by each particle, if they are parallel to one another, it is translation. If they are parallel and straight lines, they are pure translation. If they are parallel and curved lines, they are curvilinear.
Yes.
Okay, just get used to these terms. Okay, fine. No time is ready.
ಅಲ್ಲ ಸರ್ ನೀವು 8:15 ಅಲ್ಲ
Oh, ಹೌದು 8:15 ಆಯ್ತದೆ. I'm sorry.
ಅದಕ್ಕೆ
ಹೌದು ಸರ್, ಮುಗಿತು. So I think this diagram I have already shown you earlier. First class only I showed you. First class only I showed you. Correct. I changed
Yes, sir.
page color. Should be change the page color. So pure translation simply or translation, and at every end the rod remains parallel to the previous one. The points ACB are either moved in the paths, the straight line path. Another first case is called rectilinear translation. Second thing is called curvilinear translation. I hope everything is clear here.
Yes, sir.
To this point. ठीक है?
Yes, sir.
हाँ. Okay, friends.